Okay. Okay, so first of all, I know it's a very obvious question with a very obvious answer, but why do we test our code? It's very obvious that we want to make sure that whatever new code we're writing is working well, that nothing was already working in the system or in our application has broken, and that everything is working as we are expecting. And to test, we have a few ways to test. We have first the manual testing, which we're all very familiar with. You just launch the app on your phone, you go to the screen that you're testing, add some input, get output, and then just make sure that everything is working well. Whenever you add a new code, you have to open the app, go to the screen, make sure everything's working well, and just repeat the same thing. We have a few other ways of testing, unit testing, which we'll be discussing today. We have integration testing, we have end-to-end testing, we have many testing things or many approaches or types that we can use. But for today, we're going to focus on unit testing. Firstly, before going to unit testing, as we're using manual testing, what's the problem with manual testing? Why do we need to check unit testing or other things? The problem with manual testing is that it's not scalable. It takes a lot of time. Whenever I make any change in the code, I have to launch first. I have to build the app, and then the app has to run on the emulator or the phone. Then I have to open the screen that I'm looking for. If it's the first screen, then I'm lucky. But if I have like many layers, let's say login and maybe other screen, then another screen, just to test a small part of the app, just because a small change I made, this takes a lot of time. And if you're changing the code a lot and you need to test a lot, this will be a nightmare. And as well, sometimes we'll just, when we're changing a small part of the code, we'll think it's just a small thing, it didn't break anything in the code. So I'm not gonna repeat this whole process again, just working, I'm sure. But as we all know that later you find that as you did not expect, there was a problem in another part that led to the problem in the app. Sorry. And even sometimes we forget which parts of the app were affected by this small change that we made. So we even forget that we have to test another part of the app. So all of this leads to a lot of time being wasted and things that we just might forget to test it again. So a thing or a solution to boost this or to allow us to move faster a little bit with this is unit testing. What is unit testing? We know that testing is just testing the code. Unit is just a small part of our code, just one unit. It could be a class, it could be a function, a method, whatever it is, but our goal here is to try to test every small part of the application. Because if you have everything tested, every small part in the application tested, then you're achieving a very good thing, which is your code is tested, so you'd be more comfortable with it. So let's say that for an easy thing, a sample that we have a calculator. Very simple class. A dummy one even just has multiply and divide. Two methods. That's all. We're having in the first one multiply method, we're getting two numbers, multiplying them and returning the value. Then we have division. We're getting two values, dividing them and returning them. And here as well, we're adding an exception that if one value is 0, we cannot divide by 0, so we're throwing an exception. So this is a very simple class, and we want to try to add unit testing here. What do we do? Firstly, in Android, we have to get GUnit. GUnit is a library or framework that can help us in testing our code. Since we're only using it for testing, we can use test implementation, no need for the implementation. And we're gonna add, I'm sure we're all familiar with this package, this test. I used to always remove it whenever I start a project, but from now on, we would like to always keep it, since here is where our unit test will go. Android test is where our instrumented testing will go, but we're not covering this today, so we're focusing on this one today. So we added a calculator test to test our calculator class here. And now we're gonna add some code. Firstly, we need to import a few things: after, before, test, and then some methods or function from the assert class. Why? Because we're gonna use it in our test. We have a few things here. Firstly, we have before and we have after. Before, whenever we add before annotation to a function, it means that this function or this method is gonna work before any test. So if we have 3 tests, it means before every single test, this is gonna run once, then the test, then this, then another test, then this, then the third test. So this is a good place to make any initialization or any setup, any configuration that you want to make sure that it's accessible for this function. The after one, this is after every method, the after function or the after method is going to get executed. So here's a good place to do any cleanup or remove anything that you don't want to do. Let's say you have a database connection, you want to close it or anything like that. So this is before and after. And in the middle, we have our tests. This can be as many as we want. Our goal here is to try to test every possible scenario in our code to make sure that everything is working as expected. For example, here we're testing the multiply. This is just our very normal code. We're calling the multiply method that we have, and then we're passing 2 values. And then this is the new part, which is assert equal. This is coming from here, from the assert, which is JUnit that we added in our dependencies. This one helps us, just checks that 2 values are equal. So we're checking that 6, we're expecting 6 when we multiply 2 by 3. And this is the result, which is the result from this calculation. And we're doing the same to the division. We're just dividing 2 numbers, and we're expecting 2 to be the result. So we have the result, and we are assert equals that 2, our expectation, is the same as the result that we got. And we're trying as well to test that if we pass 0, that 0 is not allowed, and it's gonna throw illegal argument exception. So here, if the code works without any exception, this test is gonna fail. It tells us you're not expecting this. You told us that we're expecting an exception. So this will only be successful only if we get this exception. So I want to show you a real demo of this. Let me share my code. So I have to stop this here. And okay, I hope you can see my screen. Okay. So here I want to demonstrate what we're speaking about with 2 examples. Should be simple ones. Here I have a class, a to-do list, just a class that we're adding. We have a list here of to-do list, and then let me zoom a little bit. We have a to-do list, which is just an array or a list, and we have a function to add new to-do to it. And we have 2 functions, one get the first to-do and one get the last to-do. Just very simple push and get from the list. And here I want to make sure that if someone is passing null as an argument, that I'm throwing as well null pointer exception that this is not allowed. So this is my code, and I want to test it. Well, there is one way to do it, is that I can put it in my activity and then open the activity and all of that, but we have a faster way to do this now. I don't need to go through all of this. I can just open a new class here, just write the code here. So I defined here to do unit test. And then, as we mentioned before, in the before, I added my setup, which is just instantiating the class. And then I'm testing my new to-do. So I have in my code here, here I'm trying to add a new to-do. So I want to make sure it's working well. There is one thing that we try to follow when we're making a test, which is 3 things: arrange, act, and assert. Assert is where we test our assumption. Act is where we do an action, and arrange is just if we want to set up anything before that. So here we are arranging, we want to add this first to do, so we're making a string here with this value, and then we're adding this to my to-dos list, which is just, as we mentioned before, is just a list of array. So I'm adding it here, and then I'm querying it again. After adding it, I'm requesting it, or I'm requesting the first to do, and then I want to make sure that my code was indeed added. So I'm checking that first to do, which we added here, is indeed the first one that was added here. So this is one test. I have another scenario. Since we're using an array list here, it's working well. We don't need to make this exact test, but this is just for demonstration. Sometimes you would have more complex code, and you want to make sure that your logic is working. So here, for example, I want to make sure that whenever I'm adding new items to my to-dos, that the new ones is added to the list, to the bottom of the list. So for example, if I'm using a stack, this will be in top, but now I want to make sure that it is in the bottom. So here I'm arranging 2 items, and I'm adding 2 items to my to-dos, and I'm making sure that if I get the last to-do, it is indeed the second one, because I added the second one. And we have here another way to test an exception, if the code is throwing an exception. Here I'm trying to initiate an all to do, and then I'm passing here to my to-dos an all to do. And as we know, my code should throw an exception. So I'm using a try and catch. If this is code, it means my code crashed, or I got an exception, and I want to make sure that the message of the exception is to do cannot be null, which we already identified here. So I want to make sure that my message is being displayed. If another user or another developer is using my code, I want to make sure that they are seeing this message. And if it happens that the code did not throw exception, fail here means that force this test to fail. This means that if there's no exception, I'll get this error that null pointer exception was thrown. There's a problem in my code. And once I have all of this ready, I can just come here to do this class and then run to do. And within a few seconds, I'll be having all these methods tested, tells me everything is working well, all your test cases are correct, so I can be assured that everything is working well. This is one example. Maybe it's a very simple one that might not really need a whole test. But there is one thing that happened to me in real case. One time I was working in a company, and we had a regex. So let's say an example that I want to add a new feature where I get a link in an URL, and I want to extract the username from this URL. So we need to use regex here. So I added a pattern, and let's say that I'm using this pattern. You don't need to understand what this pattern is doing, but just the main thing is that this pattern is getting the username. So I have a method here. I'm giving a URL, and this URL, I will get from it just the username, the last part of the username. So for example, if I have this URL, we know that the username is the last part, so this will be the username. I'm expecting this from here. So I wrote a pattern, this one, and I want to test it. The best way to do it, the fastest way, is to write a unit test. Here I am. I wrote a few tests because we have so many different varieties of how the link can be given to us. It will be very time consuming to have to open the app, write every linked in URL in this way. It will take so long. But here I can just write all of this in a few seconds, and I can test many different scenarios with HTTPS, one with slash, one without HTTP, and all of that. This is one test we have here. I'm expecting that the result, I'll be passing this, and the result will be just the username of this URL. And as well, we have here another test. We need to make sure that every test cases or every case is tested. So here I'm checking that if I pass a wrong URL, that I'm not getting anything in return. I'm just getting null. Because in our code, we mentioned that if there is no match, if I cannot find or if there's a problem in this matching, that I should be getting a null here. So if I run this test, I just come here and I run my code. I see that everything is working well. Let's say that I think that there is a problem in this regex pattern, or it's not a problem, but it can be optimized. Here I'm using HTTP or HTTPS, but there is a better way to do this, which is here. I can just add this question mark to check if there's S or not. Whatever it is, I just found that there is a better way for the pattern, or I think it could do the same thing, but just with less code or whatever it is. The best way to make sure that this is working, I changed it. I can only run, or I have to only run the tests again. If everything is working, then my work is done. I don't need to worry that maybe this is not working, maybe there's a problem, all of that. And this happened in a real scenario. One time I was working in a company, and then we had a change in a pattern, and this pattern was used throughout the whole system. So it's very hard to test. So just because someone had a very long list of URLs that we're testing, or lots of tests that we're doing, it was very simple to verify that this is working or not in just 1 second or a few seconds. So let's say that by mistake, I didn't notice it. I just added another O here by mistake. I didn't notice it, but I just added it. And as well, I can, once I'm done with all my code, before pushing it to production or anything, you'll usually run all your tests. So just come here, run. This means that all of these classes, and oops, I have an error. So I'll come here and check there is an issue. Where was that? That was here, and tells me I was expecting this value, but I got null. So it was a safe net for me that if I make any mistake, any small mistake, that I can be assured that my test cases will catch this and I can fix this. So this was a simple demo. Let me get back to our presentation. Where is it? Okay. Okay. So now we're done with the demo. Why should we use unit testing? As we've seen, it helps in a few things. It firstly allows us to have a better code, because whenever you're writing the tests, you have to think about all the test cases that this code will run through, because you have a specific time that hey, this is the time to write all the test cases that will happen. So you'll think, oh, I didn't handle this one, which this happened many times to me and happened to many people, that you just realize that there's something that you didn't include in your code, so you have to fix your code. Something like null pointer exception you think about, or an empty, or whatever it is. So it helps on thinking about all the scenarios that could happen. As well, as you're writing more code, and as you're writing the code in your mind that you will be testing this code later, you'll find that you're writing a testable code. It means small parts of the code you're writing it. You don't have lots of things happening in the same function, because you know that later you'll be testing this code. So you're trying to make it as simple as possible, or as in the solid pattern, you'll have single responsibility for each function or each method. It saves a lot as well, a lot of time. You don't have to go through this whole process of testing manually, opening the application, testing all the different case scenarios. With just one run, you run all the test cases, and then you can be assured that your small change to the code is working without any issue. And as well, it results for sure in fewer errors, because any error happens, you catch it before releasing, before anything happens. You have all of this list of tests that making sure that everything is working. And if it happens that you have an error, your test will be pointing exactly to which function had this error, so you can easily fix this. So this was a very quick presentation on unit testing. And there are a few things that we could have discussed, but just because of the time, I added a list of things that can be discussed. So the first one, or the first two, is for testing in general and unit testing by the Android development team. These are very good resources. And one concept that is driven from unit testing and testing in general, which is not only for Android, it's for everything, which is test-driven development. Test-driven development is about that you first write the tests, then you write your code, which is very helpful as well, because you're directing your code towards the test. You first understand the requirements, you write everything, and after this, you start writing the code. This is a good resource as well. And then there is Mockito. Mockito is a framework or a library that helps in mocking a class. So let's say I have a class, and this class, I want to check that if this method is called, I want to return this exact value. So I'm just, with Mockito, I can tell it whenever someone, or in my test, whenever I call this function, just return this value. Just help in mocking the test instead of having to like run another class and get the results and all of that. So it's not very long, but I think it's very nice to check it out. There is the Mockito itself, which is in Java, and Android as well has examples on how to use Kotlin. So this was all. Thank you all very much. And if anyone has a question, I'll be very happy.